we're gonna be solving logarithmic equations this time. In the previous sections, we learned how to solve exponential functions, remember? And we said you have to make the bases equal to each other, like 3 to the x is equal to 3 to the x plus 1, and so on and so forth. Here, we're solving logarithmic equations. So it sort of works the same way. Let's start off with one where we have a logarithm only on one side of the equation. So here we have log base 8 of x is equal to 4 over 3. And we're going to use the definition of logarithms to do this. So let me ask you this one more time. If you have a logarithm, what is the answer to a logarithm always? It is a what? It's an exponent, right? So the answer to a logarithm is always the exponent. In here then, log base 8 of x is equal to 4 over 3. Which one is the exponent? The 4 over 3 is the exponent. As long as you can identify that as the exponent, you're on the right track, okay? Now, if every exponent needs a base, what's the base in this problem? The 8 is the base, right? So that means I have 8 to the power of 4 over 3, and that equals what? X, okay? And that equals this number here, which is x. And look, you already solved for x. Just by rewriting, you solved for x, okay?
Is that what we did before?
That is what we did before. Now we're putting it in formal equation form, okay? So let's simplify this one. We're going to rely on our knowledge of chapter 7 now. So x is equal to
16 to the power of 5.
well, say that again.
16.
So here's how we can do this. This is the cube root, right? I mean, there are so many ways to do it. If you want to do it by roots, you could do it by roots. We basically just have to identify this one. So this is the cube root of 8 to the power of 4. Do you guys remember what we did this last chapter? Okay, so now, if we start from the inside, what's the cube root of 8? 2 to the power of 4 is 16. So there we have it. That's my answer. Okay? Well, because you need to solve and then evaluate. You can't leave it as 8 to the power of 4 over 3. That could easily... What if this is on a non-calculator portion of the test? Okay? All right. So let's move on to the next one. Before I do though, could I have solved this without using roots? So if I have 8 to the power of 4 over 3, the 4 over 3 is an improper fraction, right? Could I have simplified it? 4 divided by 3 is what remainder what? 4 divided by 3? Is that 1 remainder 1?
Yes.
So could I have also written this as 8 times 8 to the 1 over 3? Remember how we simplified exponents last chapter? So this would be 8 times, how much is this? 8 to the 1 over 3. Cube root of 8, how much would that give me? 2. So either way, you get the same answer, 16. Okay? Yeah. Well, let's move on to the next one. All right, so this is, 16 is the what? The base, and this is the exponent. So 16 to the power of 5 over 2 is equal to x. All right, so let's simplify this. X is equal to the square root of 16 now to the power of what? 5. So that's what to the power of 5? 4 to the power of 5, which is how much? I know you've got your calculators on you. How much is it? 1024. Right. Okay? All right. Any questions? So we do have to simplify this. Now, what if, though, you have logarithms on both sides of the equation? All right, so what we use is property of equality. And just like in the previous section, we said if you have the same base, you can set the exponents equal to each other. It's the same with logarithms. If you have identical logarithms along with their bases, you can set the inside, the argument, equal to each other. All right? So as long as the logarithms are identical, their arguments are equal to each other. So take a look at this one. I have log base 4 and log base 4, right? They're identical to each other. So what can I set equal to each other? Right. X squared equal to negative 6x minus 8. Now, how can I solve this? Or it's a quadratic equation, right? So x squared plus 6x plus 8 equal to 0. And how can I solve this one? Factor x plus 4, x plus 2. So x is equal to negative 4 and x is equal to negative 2. Now, we can't stop there though. We have to go and check. Okay, so let's put negative 4 in there first. Okay, so if I have log base 4 of negative 4 squared, is that the same as log base 4 of negative 6 times negative 4 minus 8? All right, on the left side, I get log base 4 of 16. What do I get on the right side? Log base 4. How much is that? 24 minus 8, is that the same as 16? Yes, so does that work? Yes, okay, so x equals negative 4 definitely works. Now, you guys go ahead and check x equals negative 2. Tell me if it works. It does work for negative 2 as well. We get log of 4 equal to log of 4. That works. So the answers are both of those. Okay? All right. The other one, I have log base 5 and log base 5. Can we set the insides equal to each other? Yes or no? Yes. All right. So I'm going to give you guys 2 minutes to solve that one and check your answers and tell me what you get. So we'll come back to this. X equals 5 and x equals negative 2. But when you check, for x equals 5, you do get log of 15 equals to log of 15, so that's good. Here, automatically, when you put the negative 2 in here, you're going to get log of a negative number. That doesn't work, okay? So you can immediately take that out of the equation. Right, okay? So that much for 7.4. It's short because I took out the inequalities.